As those of you who have taken courses from me know, I love throwing in as many real-world configurations and examples and that kind of thing as I possibly can, because occasionally when I used to teach this course in person, I'd say something along the lines of, these things don't always work the way the books say they will, and at least one person in the room would look absolutely shocked. and I went through the same thing, you went through the same thing, we all went through the same thing. But here with auto negotiation, here's my real world tip for you. Leave it alone. There's no real need to mess with auto negotiation, which is exactly what we're going to do in this video. But in the real world, you use auto negotiation on both ends of a connection and you're gold. You don't even have to think about it. Years ago, when auto negotiation first came around, I'd be sitting here right behind this mic saying, for God's sake, don't use auto negotiation. I forget the euphemisms that both Wikipedia and Cisco use in their white papers and pages on auto negotiation. They're really polite about it. I'm just telling you point blank that it sucked. It was really not worth the trouble. But today it is worth the trouble. Like I said, you put it on both ends of the connection, you're done. But we're going to mess with it a little bit. One difference on the board right now and what you're going to see in the lab is that router 3 is still connected to 0/7 on MLS1. Makes no difference as far as the actual operation goes. Now, with both interfaces enabled for auto negotiation, what they're doing is sending what we call FLPs, fast link pulses, to each other. And of course, the obvious question is, fast as compared to what? It's a pretty relative term. Well, they're fast compared to normal link pulses. Bet you didn't see that coming. Here are the two side by side, and you can see in the same time frame we're getting a lot more pulses with FLPs than we are with NLPs. Now, you may say that's fascinating, but who cares? Well, actually, here's why we care. The FLP is basically a declaration of the capabilities of that sending device, saying here's my speed, here's my duplex setting, and it allows a decision as to speed and duplex that is as fast and efficient as possible without exceeding device capabilities. If the port on the other end of a connection can only run at Ethernet speed, there's no use in you sending it at gig Ethernet speed or even fast Ethernet speed, because what's going to happen? On your end, everything looks great until you start seeing, wow, we're dropping a lot of packets. Now, the fundamental auto negotiation rules. If both ports support half and full duplex is always preferred, and we're very, very grateful for that. No CSMA CD, no half duplex jazz. Now, if both ports support different speeds, the highest common speed is preferred. Again, we're very grateful for that. Makes perfect sense. And here's what happens first off. We've got router 3 and our multi-layer switch talking to each other, and they're both declaring via their FLPs, hey, the port that I have on this connection can run at up to 100 meg per second, and it can run at full duplex. Not much to decide there really, because the maximum capabilities are the same on both sides. Both ports end up running at fast Ethernet speed, and they're both set to full duplex. What happens though if we go in and screw with things and MLS1 is not running auto negotiation at all? We're going to find out, because what we're going to do is hard code the speed and duplex settings on the multi-layer switch. So right now both sides are running at auto, everything is beautiful, and we'll do a little verification on that right here. As you can see, MLS1, we're looking at port 7, full duplex, 100 meg per second, so everything is just fine. So let's make it perhaps not so fine, and we will go in on 07. And we'll look at our speed, and we've got 10, 100, and auto on a fast Ethernet port. So we're going to force it to 10. And duplex, oh, we're seeing a message already. Duplex, we're going to keep it full, but we're going to hard code it. Now you should expect to see line protocols bounce, so to speak, when you change these, and we're seeing quite a bit of that. You see the line protocol went to down, then to up, then it went down, then back to down for physical interface, and now it looks like everything's fine until we start getting this message. And I will scroll it over so we can see the entire thing. It's just a CDP4 duplex mismatch. Okay, it's kind of telling us what the problem is. Discovered on fast Ethernet, not half duplex, with router 3 fast Ethernet 0/0 half duplex. Okay, that seems odd, right? Because what did we just set on this switch? We set it to 10 for the speed, regular Ethernet speed, but we hard-coded full duplex, right? Let's do a quick show config there. Pardon me. Okay, well, we have speed 10 duplex full right there on fast Ethernet 0/7. So why are we seeing the CDP message that the other end of the connection is running at half duplex? Let's go back up to the message. Yep, just got a fresh one, so there you go. So isn't that kind of odd? It's saying 0/7 is not half duplex, and router 3's fast Ethernet 0/0 is half duplex. Kind of strange. Let's run a show interface fast 07 just to see exactly what's going on here. And we can see the full duplex setting is fine, and there's your 10 meg. So again, I know I've asked you a couple times, I'm asking again, why is the remote router suddenly running at half duplex? Let's see if we can, let's verify that. And here it is. We expect to see the speed at 10 because we hard-coded the other end of the connection for 10 meg. So it makes sense. Autonegotiation, which is still working here on router 3, is saying, okay, I detect the other side is running at 10 meg, so we'll go down to that. But half duplex, that's kind of odd. And here's exactly why that's happening. When you have one endpoint running Autonegotiation and the other end is not, what you end up with is what we call parallel detection. Now, parallel detection has some good news for us. That means the device running Autonegotiation can detect the speed of the remote device and adjust its speed accordingly. Emphasis on speed, you'll notice. Router 3 detected the 10 meg speed on the remote endpoint and set its own speed accordingly. Now, it's not all good with parallel detection, because router 3 is going to be unable to detect the remote endpoint's duplex setting. The router cannot assume full duplex. So what it does is it sets its own port to half duplex. And we just saw that with show interface. So again, router 3 using the FLPs was able to figure out the speed of MLS1's 0/7 port, no problem. But it's not going to get anything regarding the duplex. So it has to assume, okay, I got to go to my slowest duplex, my least efficient, and that is going to be half duplex. Now we have a problem, and it's a problem that's not always easy to spot. Because the thing is, we are really used to what? We are really used to seeing the line protocol go down when we have some kind of problem like this. You know, go back to your NA studies with PPP, you know, with encapsulation, with frame relay, anything. We're really used to seeing the line protocol go down when we have some kind of mismatch. Well, here we have a duplex mismatch, but that is not going to bring the line protocol down. What is going to happen is, of course, you've got one end of this connection, MLS1, who says, hey, it's fine to send and receive at the same time. And router 3 is saying I can do one or the other on that interface, but I can't do them both at the same time. So you just end up with a ton of transmission issues. Technical term, I realize. But it can be hard to spot because, again, it's not so clear cut as, oh, the line protocol is down. I got an encapsulation mismatch somewhere. I got to do something about that. It doesn't work that way. But what you'll find is if you run an analyzer on it, you start checking your drop packets, that kind of thing, you will see those packets start to drop. And you'll end up with a lot of transmission issues. So again, the line protocols are still going to run, but you're going to have some major transmission issues. I say here the real issue is the transmission speed. By that I mean the overall speed, because you've got one end running at half, the other running at full. Now, the duplex mismatches, as I mentioned, can be easy to spot if you look at the config, but it does appear that our friend CDP is more than happy to tell us about this. And as you check those timestamps, I do have the milliseconds in there, which makes for a long timestamp. Later in the course, I'll show you how to change that with a timestamp. But you can see those messages. There's another one right on time, coming in about every minute, 16, 15, 16, 17, 18. And it's just going to keep telling us, hey, you got a duplex mismatch. And that, again, is the Cisco Discovery Protocol, which is kind enough to let us know about that. So again, those are the issues you run into with a duplex mismatch, that kind of thing. A little tougher to spot, but of course, if you're looking at your console and you're looking at CDP messages, you're not just going to spot them, you will be yelled at until you do something about it. Again, in the real world, leave auto negotiation alone. For your CCNP switch exam, be ready to identify the issues that can come up, and we've seen them here in action, because the half duplex setting may not be where you would expect it to be, or really at all. So again, just one quick reminder, when you've got auto negotiation on one end, not on the other, what happens is the speed can be accurately detected, but the duplex cannot. That is it for auto negotiation, and actually for our fundamentals section. So I believe coming up next is a huge section on VLANs. Take a deep breath, and I'll see you there.